complex power. It doesn't say here, I didn't put it in bold, so you don't know whether I mean apparent power or complex power, but let's find both, because if you find complex power, the apparent power is just the magnitude of that. Okay, so we're given that our current source here is 4 angle 0. And R1 is 10 ohms. R2 is 5 ohms. ZC is negative J20. R is 10 ohms. And ZL is J20 ohms. Okay, so there are a number of different ways that we could go about this. I would look at finding let's see, the IS is coming up here, and so IS, that current source, has to equal the sum of the currents going in either direction. So I can say that IS has to equal whatever the voltage is right here over the impedance to the left-hand side, which would be R1 ZC over R1 plus ZC. So that's the current going off to the left, plus the current going off to the right would be V over R2 plus R plus ZL. Now we know what IS is. IS is 4. So 4 has to equal V times R1 plus ZC over R1 times ZC plus V times 1 over R2 plus R plus Z4. R4 equals V times R1 plus ZC over R1 times ZC plus 1 over R2 plus R plus Z. I don't know why I'm saying Z4. That's ZL. ZL. So now if I plug that in, R1 was 10 plus ZC is minus J20 over minus J200 plus 1 over 5 plus 10 plus J20 4 equals V times if I add all that together, I get 0.125 angle 8.2594. So V would equal 4 divided by that. Which is they have the conjugate of what I have. It's because, okay, this is good to know. So let me show you all this. All right, so I had my calculator set in polar mode. So let me show you what happened. This is worth knowing so you don't make the same calculator mistake. And it surprises me. And it surprises me that I didn't know this. Okay, so so first I had it set in polar mode. And then I did 10 minus J20 over minus J200. Oops. Plus 1 over 15 plus J20. So I got that answer. And then I did 4 divided by that answer. And I got that. And I said, my answer says it's 31.92 angle negative 0.82. So what it did was, now watch the difference with this. So here's that answer again. So that's the answer from doing the addition. And now if I do 4 divided by second answer, as opposed to going up and getting it, I get the right sign. So what it did was it did 4 divided by 0.25, or 4 divided by 0.25 angle. It didn't group the angle together with the magnitude. So just order of operations thing. So so the correct answer here is 31.93 angle negative 8.28. So I usually, when I use polar notation, I usually put my numbers in parentheses. I didn't that time, and it messed me up. Okay, so that is my voltage right there. I'm trying to get the complex power. Okay, so notice nowhere in here does it tell me these were root mean square, so I assume they're not. So I'm going to use my formula that the complex power is 1/2 the complex voltage times the complex current conjugate. Now, I have the voltage. To get the current, I will take my voltage that I have right here and divide it by that amount, because that'll get me the current through the load. So my complex power will be 1/2 times that voltage that I just got, 31.93 angle negative 8.28, times the conjugate of 31.93 angle negative 8.28 over that impedance, which was a 5 ohm resistor and a 10 ohm resistor. So it's the same as 15 plus the inductor was J20. And then the conjugate of that. So I'll do that calculation first. So I'll take my answer right here. So second answer, and divide by 15 plus J20, and I get 1.276 angle negative 61.38. So the conjugate would be positive 61.38. .277. So now I'll take the conjugate of that answer times that voltage from before times 1/2. Oh, do y'all see where I messed up? Do y'all know what I found? I found an answer. I didn't find the answer to the question though. I found the power through the whole part over there, right? So well, with that, let's see what we got. So 20.38 angle 53.13. 20.38 angle 53.13. Okay, so how can I get the power, what do I need to do to get the power just through the load? I squared Z would do it. I squared Z. Let me make sure are you sure that's the right formula? There's no conjugate in it? Okay.
I really don't know.
Oh, you really don't know? Okay. So I would prefer to do I would prefer to see, I do have the right current. Now to get the voltage just across, here's what I would do just to be safe. So we know we have the right current. It was this right here. That was our current conjugate. Because the current has to go through everything. So we've got that part. So let's get the voltage just across this. and that would be the current times just that impedance. So it'll be 1/2 times the actual voltage, which is 1.277 angle negative 61.38, times that impedance, which is 10 ohms plus J20 times, okay, so it is I squared, but it's the magnitude of I squared. So that's what it is. So 1.277 angle 61.38. So you said I squared Z, and it is I squared, but it's the magnitude of I squared, because that's what you get when you do this, because the angles cancel out. So 1/2 times 1.277 squared times 10 plus J20. And that's the right answer. So 18.23 angle 63.43. And what units is this? VA. So that is our complex power. Our apparent power is just the magnitude, 18.24 VA. So this is the formula that I couldn't remember. It's I squared Z, but it's the magnitude of I. Okay, any questions on that? Yeah.
What about current division work in this problem as well?
Would current division have worked? Yeah. You mean to get,
Yeah, exactly.
yes, to get the current rather, yes, it would have worked. Yep, yep. Yep.
You do the magnitude of I. Does that say you do the angle for Z and just the magnitude for I?
Yeah. So a complex number squared, it means the complex number times its conjugate, so it gets a real part, just the real part. But Z is going to have the angle. Yeah. Okay, other questions?